I'm Matt Stancliff. I work out of the New York office, mostly for Redis stuff. And you asked me here today to talk about Redis, and 4 things about Redis. So I asked you what you wanted to hear about, and you gave me 4 topics. If you didn't, then other people did it for you. You want to hear about the complexity of Redis, or managing a large open source project, use cases around Redis and other key value stores, some case studies of non-trivial things using Redis, and mistakes during Redis development over the 5 years it's been around. So we're going to hit some of these pretty quickly here and have time for questions at the end. So first off, complexity. So open source software doesn't really mean open contribution software. Just because you can see the code doesn't mean anything you change is a good idea. But a lot of people get very enthusiastic with Redis. They want to make changes, see the little features added. So people come up, and they open their pull request, and we just basically tell them, no, can't do very much, go away. But they were all happy. They thought they had the perfect little feature, and when you're not in the mindset of the person who created it, and you open kind of a blanket pull request on GitHub saying, we made this, here it is, enjoy it. We just don't know really how to accept that. They're pretty scary a lot of times. They don't meet coding conventions. You have people like coding in C who typically code in Ruby or something, and there's a mismatch between the mindset of what's expected there. And to reel in the complexity of the project to make sure it doesn't sprawl, you basically just have to tell everybody, like, unless you meet the coding guidelines and kind of the spirit of the project, we can't help you, because evaluating somebody else's code, you're all pair programming people, it's like a full-time job of getting into their mindset and figuring out what they wanted. So you can't grow the project and accept kind of blind contributions openly when you've got a development staff of 2. So one special thing about Redis is it's so widely deployed, but it's still pretty small. Like Hadoop is 2 million lines in the core of Java, and Redis is under 50,000 lines. And one of the big points about that is because Redis is so small, and we have such a small development team, it allows us to keep everything basically in our heads as to the state of the code and the live state of problems and systems as they come up. And that's both good and bad. It's good because it gives you a whole view of the system, but it's bad because you kind of don't want to break your control of having a whole view of the system. So you're constantly writing that line between accepting new features you don't understand versus rewriting everything people submit in your own way so you understand it completely. So Redis kind of has an autocratic management procedure, which is great for code quality. Salvatore is obviously the creator of Redis, and he's just an amazing coder. I think he does the work of like 10x coders just by himself. I don't know how he does it. He's just kind of amazing that way. So with this, maintaining all of the code in your own head, it's inadvertently pushing other people out who want new features. But it's great for reliability and stability of one code base, right? Because you know everything, and if you want to change something, you know the other 10 modification points you need to get in your patch to get changes done really quickly. So, as we mentioned a little before, Redis is flexible, but you can't implement all the flexible features. You have to disappoint everybody some of the time. Especially with Redis, everybody wants some little feature that's just not in the Redis kind of mindset or vision. And that does bring a lot of companies to run custom versions of Redis internally. Some companies like Twitter have dedicated internal Redis engineers where they just modify Redis and maintain it internally for their high-scale operations. So some uses of Redis and other things we can compare it against. The simplest is obviously Redis versus Memcache, right? You've got key value store, but the breakout here is No, Redis is a data structure server. It stores keys mapping to data structures, not keys mapping to necessarily blanket values. In Memcache, you may not have remembered this, but it was originally just a little Perl library wrapping libevent to get asynchronous I/O and get store things on your server efficiently. And yeah, Memcache is actually detrimental to a lot of large deployments today because of the lack of replication. Memcache is basically used to front a low-performing database. You cache your queries in Memcache to allow your kind of horrible performing MySQL thing on the back end to do its low-performing things, and you keep your hot queries fast in your cache. But when your cache goes away, you get thundering herd effect on your back-end database that can't handle the requests. And so if your cache server dies, your back-end database dies, and then your service is out. So Redis gets around that by having replication. If you've got things in your Redis cache and it's replicated, you just switch over to your replica, and your back-end database won't die. And also the funny thing about Memcache is a lot of people just use it based on the name. They want a memory cache. Oh, this thing called Memcache, it's got to be good because of the name. Let's use it. And somebody on Stackoverflow made this amazing chart. I like it because you can see as they go down further, you can see them getting kind of more excited and more deranged. So yeah, that's the best pictorial overview of Memcache versus Redis. And Memcache is, it's great. It can outperform Redis in a lot of very simple use cases, but anything more advanced, you end up duplicating Redis features in your own code base instead of letting the server handle it for you. So comparison to other data things. I'm going to dog on Mongo for a bit because we all kind of have to deal with it. So Mongo just kind of randomly stores your data, maybe, and it wakes you up in the morning when it fails. That may just be some of my opinions. But the big differences here is Mongo and CouchDB and other things in that vein are document stores. They store JSON documents and kind of nested, arbitrarily structured things. And Redis stores data structures which aren't necessarily documents. They can be components of documents, right? So MongoDB documents are JSON. Redis, all contents are just binary. It doesn't care. Anything up to 512 megabytes can be a Redis value. And going along with the document store bit, Mongo allows arbitrarily nested things, and Redis, outside of the hash data type, doesn't have multi-level data storage things. But you can always fake it by just storing a key to another Redis value as the value of your hash, right? And then kind of stack them from there. So some people kind of use these interchangeably. There was a tweet by Uber recently saying they switched from Mongo to Redis because they weren't using all the features there. They were using it as a cache, and it just didn't fit their use case, so they switched. Now, the thing you have to watch out for is a lot of people use Mongo as a complete data archive. They shove data in and hope they never have to read it back out. And that's obviously not a Redis use case because Redis is completely in memory, and memory is expensive compared to other things. You can actually go out and buy a machine with about a terabyte of memory today for around $30,000. So it's within reach, but not quite $50 for a terabyte hard drive. And Mongo has always had this kind of hybrid. We're fast because we're in memory, but we're not going to ACR write, so you may have your data, you may not. And then we're going to offload stuff to disk sometimes, maybe. So that's the basic model there. So for some things using Redis, now this is a bit tricky because we create Redis, but we don't really run any large-scale Redis services or live deployments. So a lot of these are field reports, things from other meetups when other engineers come and report on how they're using Redis internally. The biggest one locally is Twitter. Twitter is running terabytes of Redis across hundreds of servers. Every time you pull to refresh or go to their website, your information is coming directly out of Redis. for every user or for every timeline, they store the 800 most recent tweets directly in Redis. And that's why if you page down enough, your tweets just seem to stop, because that's where the Redis limit stops that's their sweet spot for memory usage versus usability. Every tweet that comes in gets replicated to 3 independent Redis servers for their just high availability needs. They like to say at their scale, the machines are failing multiple times a day, so they can't rely on anything ever being there. They have to statistically rely on their data to exist. But if something happens and they do go away, they have all these back-end kind of ground truth social data stores where they can fan out and collect their information again to repopulate the cache, but that's obviously very expensive compared to just caching it and leaving it there when you need it. And from about this time last year, they said they were doing about 30 billion Redis updates a day across all their servers, which seems like a good number, and Redis isn't falling over for them. Stackoverflow is another big Redis user. They just use it as a cache, basically a Memcache replacement, to be a little more performant, a little more reliable with replication and other things, so they can handle machine failures a lot more reliably than just non-replicated caches. And they make a point of saying that their Redis servers have 0 CPU usage. It's a fast way of getting your memory accessible over the network. And the slowest part is getting things over the network. Everything just works for them. Instagram was another huge Redis user. They've since moved away from AWS and brought all of their stuff into the kind of Facebook core architecture. But everything on Instagram that isn't an image pretty much comes out of Redis. All the feeds, all the activity, all the sessions. And they also had an interesting use case where during their migrations, they would use Redis as like a data router for storing both the old information and how it mapped to the new information in Redis, and then they would pick it off one at a time as they migrated users to new systems. Pinterest is another huge Redis user. For every user, they maintain multiple lists inside of Redis for people you follow, boards you follow, things that follow you, and even actions. Like if you follow somebody and get attached to their boards, do you unsubscribe from things that annoy you so they can try to learn what's good and what's bad inside their system? But just large Redis deployments and things they don't have to build in-house because these features work, and they're made by people who are focused around kind of data structures and algorithms who can let you abstract that away from your own business logic, as it were. I hate the term business logic. It's like you're not doing anything. But no, it's something. So mistakes during the development of Redis and all this. So as we mentioned before, with kind of Redis small code base, it all fits in one head. It allows for single-threaded development pretty much. Everything goes through one person's head and gets committed. And that can make it difficult for the community because since one person has unilateral control, and if they just start kind of brainstorming ideas in public, some people may latch onto that and say, well, that's of course coming soon because they mentioned it. Almost like an Apple rumor site or something, just because somebody hears something somewhere, it gets reported as fact. And there's not really a great way to manage people's delusions other than to not give them information to get deluded about. So that kind of brings the roadmap and other details closer in until there's a proof of concept or some code to actually show them that this is feasible. And that just ends up being a lot of kind of local feature branches that may not get pushed to GitHub until closer to when it's actually ready. And another thing here with having Redis being so widely deployed with minimal kind of developer resources is sometimes we're too focused on the code and not focused on usability or how people are interacting with the software. So sometimes you have to not write any code for a week and just talk to users about how they're using their things in production and let the issues pile up on GitHub because you can't respond to everything. That's the thing about open source software is if you're completely responsive to your users and you have a small development team, it's like taking your own agency away. You become a little robot for responding to user issues. So you've got to kind of manage yourself, and the only way to manage yourself is to sadly disappoint some users at times. But also getting away from the kind of single thread development mode is build reliable APIs and interfaces to things so other people can branch out and develop against your system without developing inside of your system, right? Yes. Yes. Okay. So one of the questionable mistakes with Redis is, should Redis code be high performance? You think, well, of course it should be. But writing high performance C code kind of limits the range of people who can contribute to your code without needing like 6 months of just being dedicated to figuring out what you're doing. So this is a segment from the new hyperlog data structure Salvatore added recently. He did this whole like multi-thousand line module in about 2 weeks. And it's full of C-isms because he's storing everything in a very tight 16K string to represent kind of a probabilistic data structure of uniqueness. And because everything's so compact, everything is just dealing with bit shifting on this 16K value. And so looking at this, probably without hours or maybe even days of playing around with it, you can't really figure out what this thing is doing. And to the right, like the top one, almost looks like Lisp. It's not, but it almost does. So that's the trade-off between, you want to be high performance, but being high performance, and like at this level, you can't write abstractions on top of it. Like these macros are the abstractions. And just kind of hiring people into these roles, it's a little trickier than typical node.js fad development when these things run the core of so many companies out there these days. You have to just be careful of what's going on. So high performance things, but limited potential for other people to come in and just improve the core if they didn't write the core, because it's not in their head. Another thing with the limited code base, or like focus on small code size and understandability, is in a sense, the entire code base is one person's kind of brain dumped into code. They made it, and they thought about it, and they wrote it down. And so coming back and reading it, you're kind of evaluating their own brain as you step through the architecture of the program, right? So all of these high-performance things lead to compact, impressive memory utilization, cache-aware data structures, and sometimes those lead to limited ability to see what's going on as well. Because you load it up in a debugger, you print the value, and you get gibberish because it's super compressed and like interleaved data structures in memory, and so you have to printf debug, which is always the best form of debugging, right? And the other interesting part is with all of these kind of high performance things, there aren't many abstractions in the way. Everything is kind of immediate and right in your face. So if you're looking at the parts of the code for config parsing, it's all just very simple parsing things in C that almost looks copy and pasted. Like tokenize is value, like string case insensitive compared to target value, do this. And then that for 100 case statements. So running through that seems a bit tedious, but it's also the best way we have to allow other people to contribute and just not get overly abstracted and just keep things as kind of as blunt as possible when they can be. There is that trade-off between the kind of opaque behavior with the bit shifting and just copy and paste stuff, and it makes a neat kind of demarcation point in the code where you have things where people can easily contribute to, and things where people, it's like off limits and they know it because they just can't even read it. So you see a lot of people wanting to commit, like almost, or they submit bike shedding PRs, like, oh, change this. This should be different. Maybe we should like change the way of doing that. And like, that's fine It comes on, and they mostly get ignored because things work as they are now, and it's just preferences at that point. And that's about all we have for the 4 points. So basically, you should use Redis, and you should be happy using Redis. Spoilers if you haven't watched Breaking Bad. Thank you. And we have time for questions, or we have a secondary presentation about cats. Questions?
I have a question about the clustering stuff. So there was a Jepsen post maybe last year.
Yes, last year.
Sentinel and replication and how that works. And I'm wondering, is that stuff still valid or accurate today, or how's that shifted?
So the question is about Kyle Kingsbury's work with Jepsen and doing kind of formal analysis of distributed systems. And what he did is he took Redis as it stands as an asynchronous replication platform and tried to do consistent tests across it. And basically anything that does asynchronous replication is never guaranteed to be consistent because there is a perceptible delay between when your result comes back and when it gets persisted off node. Some good work did come out of that. A lot of the Sentinel stuff was rewritten to be more consensus-driven, to have a more complete view of what all of the nodes are doing. And there was a new statement introduced called wait that allows you to specify the number of nodes that should acknowledge the write before you get your return back. So you run like wait 3, set AB, and then your set will not return success until at least 3 other nodes have been replicated to and acknowledged. So that's kind of a workaround for completely async replication. It brings it up to par if you're willing to gate all of your important sets with that. So yeah. And Kyle's done a lot of great work across all the systems, and he's basically shown nothing works using the default guarantees, because the default guarantees everywhere are in memory, return, persist later. And that's the only way you get high performance. But yeah, don't use that for accounting systems. Just stay with your Postgres for accounting. Questions? Yes?
People submitting pull requests, right? And large companies seem to just fork Redis and in their own copy. But does Redis get influenced by some of the popular other tools that work with Redis, like Apache Storm or some of the other things that tend to be popular to write to it? Like is Redis friends with some of the other frameworks and things that write to it?
Right. So the question is about how Redis development kind of plans against other things using Redis. Like, is it made to be friendly with other services using Redis intentionally? Or do other services just kind of program around how Redis is for... Right. So one of the special things about Redis is it's such great complementary infrastructure for so many other services that they can just be kind of thrown in place. Some people refer to Redis as their go faster sauce. As far as the development direction of Redis in concert with other products and other services, they're kind of ignored. Which is also one of the reasons I think Redis got popular, is because Salvatore just went along and did the right thing in so many ways and didn't try to be fad-driven or local kind of temporally popular-driven by anything. He just went out and made data structures and then made them fast and replicated, and that's just what people started liking to use. So he likes to stay in the mindset of do the right thing and everybody else will be able to use your service. Come on, we can do 3 questions. Yes. Again? Go for it. Speak up a bit.
Is there, so Redis supports like random updates, right? From what I understand. Is there, how much of the code would you say is like dedicated to that? And is there have you seen any flavors or forks of Redis where some immutability, forced immutability or event-only kinds of things are introduced that improve performance or something.
What do you mean random updates? Do you mean just...
I mean, obviously, it's
Right, okay.
Is there flavors of Redis where the idea is that these are persistent data structures or immutable?
No, that's clever. So the question is, has anybody played around with Redis in a way, like, no, write once, read many way, where everything's immutable once you set it, except for a delete, I imagine. Not that I'm aware of, because most people use Redis for high-frequency updates. Some customers have used Redis as just a pure cache over data that's kind of materialized overnight. So at night, they'll create this big batch of data, load it into Redis, and then all their services will only read from it during the day. That's more of a use case than a code restriction, but it's great in that environment as well. And obviously, when you're running a Redis server, if you can limit the types of operations you perform on it, that's better for cache coherency in your instruction cache and your data cache as well. So if you're doing a bunch of just string gets and sets, it's great to have that in one server. And then if you have a bunch of like long list operations that only does long list traversals, that's great to set off in kind of another server. And Redis is super lightweight. When you start it up, it's under a meg of RAM just sitting idle. So you can easily run 10 to 20 Redis servers per like activity your software is doing on one server. I tend to run individual Redis servers like they're individual databases in other systems. So like one Redis server per project, not like a one MySQL server per system, then multiple things inside of it.
So there's like a standard kind of cache invalidation problem called like the thundering herd, right?
Right.
You get a cache miss, so you want to go fill that cache. But if you have a whole bunch of requests coming in, the backend database is going to have to service all of them before the cache that come in before the cache comes in. So you want to hold all those requests till the cache gets, repopulated, and then just have them all read out the cache, right? So you don't swamp your database backend. Are you familiar with that?
Yeah.
Yeah. So I was wondering, what in the Redis world is there a cool or standard way of dealing with that situation?
So the question is about thundering herd, and is there a way to kind of back up requests until the cache is warmed up? That's kind of outside of the Redis architecture. So that would be more like a layer in front of Redis you are requesting through. And so if your cache servers were down, it would just queue up your requests until either it determined the cache was big enough or was warm enough for that.
And I know that Redis doesn't do that. I was just wondering if they're in the Redis ecosystem, is there like a standard?
Oh, is there something that would do that? It's not that I'm aware of. That seems kind of like very architecture dependent of your application. And it seems almost trivial to write. Like it would be another Redis service in front of your cache Redis service, right? That could do it. Yeah. So basically, if your backend cache is down, just queue things in the front end until you get an act that things are there. Yeah, I hadn't thought of actually queuing requests instead of just denying them or passing them through. But yeah, that's a good idea. I'll look into that. Okay, thank you.